Now we're going to talk about two basic rules of probability. The first one is sometimes referred to as the addition rule. The probability of getting event A or event B can be written as the probability of A in union with B. This is equal to the probability of event A occurring plus the probability of event B occurring minus the probability of event A and event B occurring together. So make sure you know this. Now sometimes you may be dealing with two events that are mutually exclusive. For mutually exclusive events, the probability of getting event A and B together is 0. So therefore, the probability of getting A or B becomes P of A plus P of B if A and B are mutually exclusive events. But you can always use this formula, which will always work regardless of what type of events you're dealing with. The next type of rule is the multiplication rule. So let's say first let's talk about conditional probability. The probability of A given B is the probability of getting A and B divided by the probability of getting B. So what this means is that if we multiply both sides by P of B, we can get this equation. The probability of getting A and B is the product of the probability of getting A given B times the probability of event B occurring. Now, what about this scenario? What is the probability of B given A? This is still the probability of A and B occurring, but divided by the probability of A. So if we rearrange this equation by multiplying both sides by P of A, we can see that the probability of A and B can also be written as the probability of B given A times the probability of A. So notice the similarities of these two equations. Now sometimes the two events that you're dealing with might be independent events. An independent event is an event that does not depend on another event. For independent events, the probability of A given B is equal to the probability of event A occurring, because A does not depend on B. Likewise, the probability of B given A is equal to the probability of event B occurring, because B does not depend on A. So when dealing with independent events, we get this equation. The probability of A and B occurring is simply the probability of A times, not plus, but times the probability of event B occurring, if the events are independent. If not, then you can get one of these equations, depending on what you're given. One thing I do want to mention is that when you see A and B occurring, this means that these two events are occurring at the same time. It doesn't mean A and then B, which could be different from B and then A. So because the events occur at the same time, the order is not relevant. Otherwise, the formulas may be affected. So just keep that in mind. Therefore, the probability of A and B occurring is the same as the probability of B and A occurring, because these two events occur at the same time. So I just want to add that clarification for those of you who may have questions on it. Now, let's go ahead and put this information to good use. Sarah is deciding which courses she wants to take in her next college semester. The probability that she enrolls in an algebra course is 0.30, and the probability that she enrolls in a biology course is 0.70. The probability that she will enroll in an algebra course given that she enrolls in a bio course is 0.40. So part A, what is the probability that she will enroll in both an algebra course and a biology course? So take a minute, pause the video, and using the formulas that we discuss, go ahead and get the answers to these questions. So first, let's begin by writing down what we know. The probability that she takes an algebra course, that is P of A, is 0.30. And the probability that she takes a bio course, that's 0.70. Now, the probability of A given B, that is, that she takes an algebra course given that she takes a bio course, that's 0.40. So with this information, we can now focus on part A. So we're looking for the probability that she will take both algebra and bio. So what's the formula for this? This is equal to the probability of A given B times the probability of event B occurring. So we can see that P of A given B is 0.40, and the probability that she will take a bio course is 0.70. Now 4 times 7 is 28, so 0.4 times 0.7 is 0.28. So there's a 28% chance that she's going to take both algebra and biology. Now let's move on to part B. What is the probability that she will enroll in an algebra course or a biology course? So this time, we're looking for P of A or B. So what's the formula for this? So this is going to be based on the addition rule as opposed to the multiplication rule. So this is P of A plus P of B minus P of A and B. Now the probability that event A will occur is 0.3. And the probability that she's going to take the biology course is 0.7. The probability that she will take both algebra and biology, we have it here, that is 0.28. So let's go ahead and subtract these numbers. So 0.3 plus 0.7 minus 0.28, this is equal to 0.72. So there's a 72% chance that she will take algebra or biology. Now let's move on to part C. Are the two events independent? What would you say? What are the requirements for two events to be independent? In order for events A and B to be independent, the probability of A given B must be equal to the probability of A. Are they equal? The probability of A given B, we could see that it's 0.4. And the probability of event A occurring is 0.3. So these two are not equal. Therefore, the two events are not independent of each other. Now, what about part D? Are the two events mutually exclusive? What would you say? In order for the two events to be mutually exclusive, the probability of event A occurring and event B occurring must be equal to 0. Is this true? Well, we know that A and B, the probability of these two events occurring is 0.28 because that's what we calculated in part A. So it does not equal 0, which means that events A and B are not mutually exclusive events.